graphite. It is also found in the form of coal. It is also found in the form of diamond. Okay, but graphite is the purest form. We consider that graphite is the original form of carbon. Okay, and moreover, if I talk about this one, that it occurs in atmosphere in percentage, that is 0.03% in the form of carbon dioxide in atmosphere. Okay, everybody understood? So please note it down. Please note it down that uh, please note it down. Carbon exists in nature in the atmosphere in the form of carbon dioxide. Okay, this question comes for 1 marks. Okay, and this carbon occurs in earth crust in percentage, that is 0.02% in the form of coal and petroleum. Okay, so please note it down. Please note it down. Noted here, students.
No, sir.
Please only this two statement you have to note it. Okay.
Okay. Yes, sir. Don't.
Only the two statements. Only the two statements you have to note it.
Yes,
Okay?
another.
Moving to the next part here, that first of all, let me explain you that why we are studying carbon and its compound chapter, and why we have a specifically designed chapter for this special compound, that is carbon, and why carbon is going to have so many compounds other than any elements in the whole periodic table. Carbons have specifically more than 3 million compound known till date. Okay, and we can simply say that we have separated the branch of carbon, means there's a chemistry in which we studied about the hydrogen and carbon, that is called hydrocarbon. What we called it? Hydrocarbon. You understood?
Yes.
Okay. So hydrocarbon, or with the study of carbon, means compound that deals with the study of carbon, then only we have separated into another branch of chemistry, that is called organic chemistry. So this is the branch that we study, or we can say that this is the part of organic chemistry chapter, and this is very important chapter for the 10th standard, not only for the 10th standard, but also for it is a base for the organic chemistry that we're going to study in the higher classes. Okay, so this chapter is very important and no one is going to get any absent, or please let me remind you that this chapter is very important. It is a basic for organic chemistry. Whatever you are going to study here in this chapter, we're going to have advanced version in 11th and 12th standard. So please do not miss a single class. Okay. So let's move that why carbon is considered to be as why it is forming large number of compounds. So why is carbon so versatile in nature? This question comes in examination, that why carbon is considered to be as so versatile. Why there is why carbon wants everyone to be his friend. Okay, in NCERT, carbon, there is a statement that will you be my friend? Will you be my friend means why is so versatile nature? Why carbon is going to make bond with every other element? So the reason for this one, let me explain you that why carbon is going to have large number of compounds. So if we have the stable electronic configuration, or we can, if I talk about the electronic configuration of first 20 elements, okay, if I wrote it here, so these are the first 20 elements, okay, that is going to have their electronic configuration as written here. Okay, so if you like this one, that if I'm having this hydrogen, it is going to have 1, it is going to have 2, then 2,1, then 2,2, 2,3, 2,4, 2,5, 2,6, 2,7. Okay, understood? And then 28 neon, then sodium 281, then magnesium 282, then aluminum 283, then silicon 284. Okay, and then 285, then 286, then 287, then 288. Okay, So if you consider that, which is the first element that is going to have 4 electrons in their outermost shell? Which element is
Hydrogen.
going to have? Carbon. Carbon is the first element that is going to have 4 electrons in their outermost shell. And what is the benefit of this 4 electron? That carbon is the first one that is going to have 4 electrons in their outermost shell. And after carbon, and the next one is silicon. After the carbon, the next one is silicon that is going to have 4 electrons in their outermost shell. So what is the advantage of having this 4 electron in their outermost shell? So advantage for this one is that advantage for this tetravalency, for tetravalent, that it can make bond with 4 different atoms at a single time. Okay, or similar atom at the single time. So means it can bond with 4 carbon atoms. It can bond with 4 different atoms at a single time. So for example, if I talked about this lithium has only one valency. So it can make bond only with one other atoms. It can make bond with 2 other atoms. It can make bond with 3 other. Coming to the nitrogen, it will not make bond with 5. It will make bond with 4 atoms. Sorry, 3 atoms, because nitrogen need only 3 electrons, because it is going to have 5 electrons in its outermost shell. Okay, so it required only nitrogen require only 3 electrons to bond to complete its octet. So it will bond with 3 hydrogen atoms like this, and will form ammonia. Okay, and will complete its octet also. We'll discuss this structure. But later, talking about this one, that carbon is the first element that is going to have 4 electrons in the outermost shell. So that's why it can make bond with 4 different atoms. Nitrogen having 5, but it cannot make bond with 5. It will make bond with 4. Oxygen having 6, it will not make bond with 6. It will make bond with 2, because its valency is 2, because it need only 2 electrons to complete its octet. Fluorine will make bond with only 1, because it's need only 1 electron to complete its octet. Okay, you understood? Understood? So if the next question comes here, that why, if we are just talking about the tetravalency, so silicon is also going to have 8 electrons in its outermost shell. If I'm talking about tetravalency, then silicon is also going to have 4 electrons in its outermost shell. So why if having this carbon and having this silicon, both are tetravalent, but why we are saying that carbon is going to make more stable bonds rather than silicon? Why there are millions of compounds of carbons, not of silicons? Why carbon can combine together in thousands of carbon atom bonded together in a straight chain in branch? Why not silicon can make or combine with other silicon atoms and form long chain? Why? There is a reason behind this. Why carbon is making so stable bond, and why not silicon? Because if I'm talking about tetravalency, there must be a comparison between silicon and carbon, because other tetravalent, next tetravalent is only silicon. After carbon, we have silicon. So if we're taking the tetravalency, because of tetravalency, carbon is going to make millions of compounds and not. So we should compare it. We should answer it with the another. We should compare it with the silicon. That why silicon is not going to make, because tetravalency, if I'm talking about tetravalency, the other elements are going also tetravalent. Then why, what is that special in carbon, not in silicon, that is making it so versatile in nature? So let me discuss here. So if I talked about this carbon is the atom that is going to have 2 in the first shell and 1, 2, 3, 4 in the second shell. Okay, that is 2, 4, that is carbon. And now talking about the silicon, that is silicon is going to have 2 in the first shell, then 8 in the second shell, 1, 2, 3, 4, 5, 6, 7, 8, and then it is going to have next 4 electrons in its outermost shell. Okay, that is 1, 2, 3, 4. Now you understood? Okay, so what is the difference between these two atoms? Can you figure out that what is the difference between this silicon atoms and this carbon atoms? This is silicon, this is carbon, and this is silicon. Can anyone in the class can compare these two atoms? That what is the difference?
Silicon is huge.
Yes, these are the bigger in size. The first you can see literally here that silicon atom is bigger in size because it is going to have an extra shell.
8.
Okay. So if I talked about that, if silicon is going to make bond, so this, like for example, if it is making bond with hydrogen atoms, so this is hydrogen atom. This is hydrogen atom, this is hydrogen atom, this is hydrogen atoms, okay? And this is another, if carbon is going to make bond with this. So here you will find that, that duplet, hydrogen is completing its duplet. Hydrogen is completing its duplet like this, or make like this, okay? And here it is going to complete its duplet. And silicon is also going to have 8. 1, 2, 3, 4, 5, 6, 7, 8. That's why silicon is going to have 8. And this is also going to have 8. But actually, these are the bonded pair of electrons. And who is going to hold this bonded pair of electrons? Which particles or which subatomic particle is responsible for holding electrons? Proton, positively charged particles, okay? So positively charged particle of an atom is present in, positively charged particle of an atom is present in which part? Tell me. Positively charged particle is present in nucleus, okay, in the nucleus. So nucleus is nearer because of a small size. Nucleus is nearer to this bonded pair of electron. Nucleus is nearer, the distance to the bonded pair of electron, to the bonded pair of electrons in carbon is smaller than the distance to the bonded pair of electrons in silicon is, okay. You can simply say that in carbon, there is a shorter distance between the nucleus and the bonded pair of electrons. And in silicon, there is a greater distance, or we can say more distance between the bonded pair of electrons. Okay, you understood? Okay. So you know that nucleus is going to hold the electrons, or positively charged particle present in the nucleus. They are going to hold the bounded pair of electrons. So if the distance is greater, the weaker will be the force. Okay, weaker will be the force. And here, if the distance is smaller, the stronger will be the force. Okay, got it? So we can say that in carbon, the effective nuclear force to the bonded pair of electron is more. Effective nuclear force to the bonded pair of electron is more. But here one question can comes in your mind, that if I talked about the powerful power of the nucleus of carbon and that of silicon. So if I talked about the power of nucleus of carbon and silicon. So you will notice here that in silicon, there are 14 proton. There are 14 proton present in the nucleus of carbon. And here in the nucleus of carbon, we're going to have 6 proton. And in nucleus of silicon, there are 14 proton. Okay, 14, because the atomic number of silicon is 14. And the number of proton is exactly equal to the number of electrons. So if it has 14 electrons, so it must have 14 proton. Similarly, if carbon is going to have 6 electron, so it must have 6 proton. So if I talked about your simple word, that you can also say a simple question here, or you can arise a simple question that, sir, it's okay that the distance between the bonded pair of electrons and silicon is more, okay, as comparison to carbon. But the nucleus of silicon is also powerful. It is going to have 14 electrons. So it is going to have 14 electrons. So it is powerful. Then as comparison to it, it's 2 times powerful. It is more than 2 times powerful than the nucleus of this one. So it can hold it. So why it is not, it may contradict here. Your statement may contradict that with this one, that why still the nucleus of silicon is 14, going to have 14 proton. It is powerful than the nucleus of carbon. Then why the bond is not so stable? Okay. So can anybody in the class answer me this question? Can anybody in the class can answer me this question? No.
The silicon is not stable, right, sir?
The silicon is not stable. Why?
Because it has more numbers of electrons.
Because it is going to have more number of electrons. So, but it is powerful. So let me explain you. Just imagine that you are going to have a fan, okay? A fan. Let me explain you with the example of fan. For example, if you are going to have a fan, that is going to have 2 blades only, okay? And if it is rotating, so in this area in which this is rotating, the background things will be visible to you. Or you can say if it is a ceiling fan of 2 blade, then the ceiling will be will appear to you. Will it be visible to you?
Yeah, yes, sir.
Yeah.
Mm.
And if I increase the 4 blade, then will the ceiling will appear will with that one, or will it be less visible as comparison to previous one?
I think it will be the same. I don't
No,
know.
no, because we are just increasing the
Little
surface
dark.
area. So
Yeah.
yeah, it will be. Now, if I increase the blade,
Yeah, more darker.
okay, a condition will comes here. If I increase the number of blades here, and if the fan is rotating with the same speed, then in that time you will notice that the ceiling will not be visible to you. Okay,
Mm.
okay, because every time blade is there, when it is going to have 2 blades only, then we have more empty area. Okay, but if we are having more blades, so more area will be occupied by the blade, and the less area will be visible for left for the ceilings. Okay, so in this case the ceiling will be visible to you, but in this case ceiling will not be visible to you much as comparison to that one. Okay, similar is the case uh for the case in case of silicon. We have this structure of silicon. Okay, and this is the nucleus, and these are the 2 electrons. Here are 2 electrons, but these 8 electrons, when they are revolving around the nucleus, when they are revolving, they make an electron cloud. When they are revolving, they like a fan is rotating. So when a fan blade is rotated, then it makes a cloud like structures, a blur structures around in which area it is revolving. Similarly, when these electrons are revolving around this nucleus, they will make a cloud here, electron cloud. Okay, they will make an electron cloud, and due to that, this nucleus will not be visible to that. Still it is powerful, but it will not be the positive charge of this nucleus will not be visible, or will not be able to reach to this bonded pair of electrons. Okay, like if you are having sun on a very hot day, but if there is cloudy, if there is rainy season, you see that. Can you say that on the cloudy day the sun temperature is low? No, because on the cloudy day the clouds comes in between the sun and you. That's why the radiation of the sunlight, or the heat of the sunlight, is not directly affecting you as it was previously when there was no clouds. Okay, you understood what I'm
Yes,
saying?
sir. Yeah.
Similarly, this electron cloud just behave as a cloud like in the sun, and the heat of the sun, like on the cloudy day, heat of the sun will not directly affects you. So in a similar way, when these electrons will rotate around about this one, they will make an electron cloud that is called shielding effect. What we call it in chemistry, it is called shielding effect. Shielding effect. Okay, and due to this shielding effect, still the nucleus is powerful, but its positive charge will not reach to this bonded pair of electrons, and the bond formed here is weaker, not so stable bond. Okay, as comparison, since in carbon there's only 2 electrons, here is 2, and this 8 electron is the outer, here this is outermost electrons, and we can simply say here that this there is no shielding, that we can say that is poor shielding. Okay, and due to poor shielding in carbon, this nucleus is visible to this one, and we can say that it is sufficient to hold this bonded pair of electrons. Okay, you understood? Everyone in the class understood? So
Yes,
first is
sir.
the small size, and the second one is shielding effect, that is making the bond very stable. Okay, so please draw this structure and start writing this one. Please draw this structure. That the first one is tetravalency, that you write here, tetravalency. Write it, this one. Tetravalency, it has 4 valency. It can make bond with 4 similar or different atoms at a time. Okay, note it down. Done. Done, dear students. Noted. This is statement only.
Yes, sir.
Yes, sir.
Tetravalency. Okay. So because of tetravalency, it is able to make bond with 4 different or similar kinds of atoms. Okay. The second one is electronic. If I talk about a small size. Okay. So note it down. Make this structure both of of carbon and silicon, and note it down. Due to small size of carbon, the effective nuclear force in carbon to bonded pair of electron is more. This help it make it more stable bond or a stronger bond. Note it down. And
Sir, at last, stable bond or then what you wrote, sir?
a stable bond or a stronger bond.
Okay, sir.
Stable bond or a stronger bond.
Then, sir.
Done. Is there anyone still writing? Because of poor shielding effect of carbon, then silicon. Okay. Got it?
Yes.
The next one is, if I talked about this one, the next one is covalent bond. What is covalent bond? Let me explain you what is covalent bond. Okay. So if I talked about covalent bond is a bond that is formed by sharing of electrons. Okay. And it is not an easy, or we can say that it is not a simple or means it is a stronger bond. After the ionic bond, covalent bond is the stronger bond, and we cannot say that it is a very easily breakable bond. No, in chemistry, it is the second strongest bond, and it requires large amount of energy to break this bond. Okay, so it is not an easy task because carbon make bond by sharing of electrons, and that is a covalent bond. Covalent bond is the bond that is formed by sharing of electrons. Okay, since carbon is going to have 4 electron in their outer motion. Okay, so it can neither gain 4 electrons, because for that a powerful nucleus is being required. For that, a powerful nucleus is being required to hold, because it is going to have only 6 proton. So if it by if it borrow 4 electrons, then what would happens? For example, first it gain 1 electron, then it gain 2 electrons. So it is very tough for this one to hold 8 electrons, for this 6 proton only to hold 8 electron. Moreover, due to small size, for example, if this is a small size of carbon atom, let's put this is the 2 shells, first 2 shells, okay, and these are the first shell, and it is going to have 2 electrons, and then this is the second shell. Okay, this is the second shell, and this is the second shell. Okay, so if due to small size, okay, if it start adding more electrons, then what would happen? There will be a congestion. Will take place, because when extra electrons come to its orbit, there is an electron pair repulsion, means electron repel electrons, because electrons are negatively charged. So they will start repelling each other. No, they will not like to have electrons, okay, because electron repel each other. So it is very means you can say that carbon cannot form C4 negative ions by gaining 4 electron permanently, because the nucleus is not so powerful that it can hold 8 or 10 electrons, total 10 electrons. Okay, 6 are already and 4 extra. So it cannot hold this because nucleus is not so powerful, and moreover there is an electron pair repulsions when electrons come into the orbit because of a small size. For example, if it is bigger size, that it might be a third shell or fourth shell, then that shell is bigger in size. So if this is a fourth shell or third shell that is bigger in size, so it can have 8 electrons easily, because there is a more space. But if this is a small size second shell, then 4 is already present here. Then if you add extra, then they come very close to each other. Okay, and because of that they will repel each other. So if it is it might be third shell, then it is easier. But if fourth shell, in the second shell, it is not easy to hold 8 electrons. Okay, because it is a second shell. Okay, you understood?
Yes, sir.
Yes, sir.
Okay. Moreover, if I talk about that, why it cannot lose 4 electrons, why to have the electronic configuration to the nearest noble gas, that is helium. So why it cannot lose the 4 electrons? For example, if it is this 2 electrons and this is 4, 1 2 3 4. So if it start losing this one, so in that case the size of the atom will instantly decrease when it lose 1 electrons. Okay, the size of the atom will decrease. Why? Because this times here 6 proton, 6 electrons are there, but here 6 proton and 5 electrons. And when it becomes when it loses 1 extra, okay, then this is 6 proton and 4 electrons. So as the size of the atom decreases, size of the atom is continuously decreasing, then it will require much energy, more energy to remove the electrons. Means next electrons. For example, to remove the electrons, it take, for example, 1000 joule energy. For example, just explaining you, it will take much more than this one. Okay, now for removing the third shell, now this shell has come closer to the nucleus because of the greater number of proton are attracting the lesser number of electrons, or we can say because of the size of the atom is decreases when 1 electron is loses. Okay, then this time it will take 2000 joule or more than 2000 joule. Okay, then in the next time it will take more than 4000. So it is exponentially increasing to increase when 1 electron, then next electron, then a next electron. So there is a large amount of energy is being required to remove this electron, and this is not practically possible to remove all the 4 electrons. So for this carbon is going to share its electron. Carbon can gain 4 electrons and become C4 negative, because nucleus is not so powerful. Electron pair repulsion is there. Moreover, why carbon cannot lose 4 electrons? Because this time when carbon is losing 4 electrons, then large amount of energy will be required to remove 4 electrons, and this is not practically possible to remove this one. Okay, you understood? Now what does carbon do? Carbon shares the electrons. So it is carbon, it is 4 electrons of carbon. Now it is making bond with a hydrogen atom, for example. Okay, so for some time, this carbon's electron will revolve in this hydrogen atoms, and the hydrogen atom is going to have its duplet too. It will complete its duplet, and for okay, and wait a minute. Oh. Wait a minute, dear students. Okay, dear student, is I'm audible to you? Hello, is I'm audible to you?
Yes, sir.
Yes, sir.
Okay, so wait a minute. So let's talk about this one. Okay, so I was just discussing here that this carbon atoms, okay, so it starts sharing electrons. Why? Because there is a large amount of energy is required to remove all four, and it is very hard to hold 10 electron per 6 proton. Okay, so that's why it form bond by sharing electrons. Okay, so that's why I was explaining here that it will start sharing like this way, and this here the octet of carbon will also be completed like this. And this type of bond is called covalent bond, and it is the strongest bond in the chemistry. Okay. Okay. So note it down. Covalent bond. The second, third one was first. We have discussed is tetravalency. Because of tetravalency, carbon can make bond with four different or similar kinds of atom. Second one is a small size, and third one is covalent bond. Okay, due to covalent bond, this since it carbon has four valence electrons, so it make bond by sharing four electrons to complete its socket. Such bond is called covalent bond. Okay, covalent bond is stable and second strongest bond in the ionic. Okay, and that's why it forms stable bonds. So it is the second strongest bond after the ionic bond. Okay, so the bonds formed by, we can say that it is stronger since it is forming a stronger bond. So the bond is stable. Okay, you understood? You understood?
Yes, sir.
Yes, sir.
So please note it down. Covalent bond. Hey, students, may I know that is there any background noise coming to your to you?
No, sir.
Is it coming or not?
No, no.
Okay. So done. This one. Done. Dear students. Noted.
So one second.
Is there anyone still writing?
So 1 second.
Okay, noted. Noted fast.
Done, sir.
Done. Okay. So moving to the next part here is okay. So let's move further. If I talk about the catenation, what is catenation? What is catenation? So catenation is a self-linking property of an element. Catenation is the self-linking property of an element, okay, by which an atom can make bonds to its similar or own kind atom. So what I'm talking about is that catenation is a property, self-linking property, okay, by which an element can make bonds to its similar kinds of atom. For example, here oxygen atom, here another oxygen atom, they are just bonding together. Chlorine atom, they are just bonding together, okay. This oxygen atom, this oxygen atom, this oxygen atom is bonding together, okay. So if I talk about this one, that sulfur, okay, uh, sulfur, sulfur atoms are bonded together, they form sulfur, okay, and P5 atoms, S8 atoms. So if I'm talking about that, if I'm talking that, what is catenation? So catenation is a self-linking property of an element by which it can make bonds to its own or similar kinds of atoms. Okay, you understood?
Yes,
Understood?
sir. Yeah. Yes.
So ozone here. So oxygen can show catenation property up to 3 atoms. Ozone. Sulfur can show catenation property up to 8 elements, 8 atoms bonded together. Chlorine can show catenation property up to 2 atoms. Phosphorus can show up to 5. Okay. But what about carbon? Carbon show catenation property to the maximum extent. Means it can in carbon shows this property to the maximum extent. Why is it showing? Because of the above 3 reasons. Because of tetravalency, that other elements have, silicon have, but due to small size, it make it extraordinary. And third one is covalent bond. Covalent bond is also found by other element, but because of small size and tetravalency, carbon show catenation property to the maximum extent. Carbon show catenation property to the maximum extent. So many times this question is being asked in the examination that what is catenation property? So note it down. Catenation property is a self-linking property of an element. Note it down. Catenation is a self-linking property of an element by which an element can make bond with its own kind or similar atoms. Okay. Example OOCl2 and this one they are showing catenation. But in case of carbon, we can say that in case of carbon, due to small size covalent bond in tetravalency, carbon show catenation property to the maximum extent. Why it is showing maximum extent? Because it has smaller size covalent bond and tetravalency that we have studied. And as a result of this, carbon can make bonds or compounds in branches, like in a straight chain, like in branches like this. Here, carbon atoms bonded together like this. Okay. So they can make bond in branches, they can make bond in a straight chain, they can make compounds in the rings, like here, benzene. Okay. So they can make bond in rings. So they are the reason why the carbon is going to have large number of compounds. The only reason is that it can make bond with it show the maximum catenation property to the maximum extent because of the above three reasons that we have studied. Okay. Noted. Noted.
Okay, sir.
Note it down, please.
Yeah, how much should I write?
Hmm?
Till how much should I write?
You have to write here till here.
Uh, Nancy.
Okay. Is there anyone who's writing? Is there anyone? Okay. So should I move further? So
Yes,
because
sir.
of this, because of these reasons, we can simply say here that carbon is going to make so many compounds. Okay. Because of these reasons. Okay. You understood? Now
Yes,
talking
sir.
about this, Now talking about this one. Next, there's a question comes in examination that both silicon and carbon are going to have tetravalency. Okay, and this is an NCERT question, and so many times this is being asked in the examinations also, that both carbon and silicons are tetravalent, but carbon forms thousands of hundreds of carbon joined together. The bond is stable, is still stable. But why, if I talked about the silicon, why silicon is not able to make large number of compounds? Still it has 4 electrons. It is also tetravalent. The reason behind this that we have discussed, so please note it down, this question in your copy, that both silicon and carbon are tetravalent, but silicon can make chain up to 7 to 8 carbon atom bonded together, while carbon can make chain, note it down, okay, and up to thousands of hundreds of carbon atoms joined together. So why is carbon making so many large number of compounds? Still both are tetravalent. So reason behind this we have discussed, that because in carbon, you know that carbon is going to have a small size, so effective nuclear force to the bonded pair of electrons, because carbon is small in size, carbon has 2 shell, silicon has 3 shell. The bonded pair of electrons, means the electrons that are being bonded, has more effective nuclear force. Effective means the nuclear force that is effectively acting on the electrons. So carbon has more effective nuclear force than the nuclear force than the bonded pair of electrons in silicon. As a result, more stable bond is formed in the carbon. Okay. Second is carbon. In carbon, the shielding effect is poor or less. Okay. Then silicon. So the effective nuclear force, or Z, is Z effect. Nuclear force is called Z effect. Okay. Is in carbon is more than silicon to the bonded pair of electrons. So please note it down. This question comes so many times in examination. Please note it down. This is important. When you're done, please let me know. Okay. Are you writing?
Yes,
Yes,
sir.
sir. Please.
Note it fast.
Answer.
No, sir.
Done?
No,
Yes,
sir.
sir.
No, sir. No, no, no. Done, sir. Done.
Okay. So here also, is there still anyone is still writing? Is there anyone who is still writing? Ashwin, you got it?
Yes, sir, done.
Okay. Now moving to the next one is this question comes in the previous exams in 2022. Okay. Okay. What this question comes at why carbon cannot form C4 positive ion and by losing its 4 electrons, or why it cannot gain 4 electrons permanently. So this question you have to write. I'm just going to explain you. I've explained you this one also, but you have to take the screenshot for this one because you have to write it in homework. Okay. So we'll give you the homework for this question. The question is the bond formed by why carbon cannot lose 4 electrons. Okay. Uh, Permanently. So this is the answer that here you see that this is a 6 electron and 6 proton. So when as it continuously loses its electron, okay. So here the the protons are attracting the 5 electrons. Here the 6 proton are attracting the 4 electrons. And since the greater number of proton are attracting the lesser number of electrons, the size of the atom will shrink. And due to small size, the bonded pair of electron or the outermost shell of carbon will come closer to the nucleus. And when it is coming closer to the nucleus, so it is very tough to remove the next electron. So because of a small size, it is continuously coming closer to the nucleus. So for removing this electron, it is very difficult. Okay, because it is coming closer to the nucleus, and more powerful nucleus will be energy will be required here. So we can say that since as the atom start losing its electron, the size of the atom decreases. The size of the atom decreases because greater number of protons are attracting the lesser number of electrons. Okay, greater number of protons are attracting the lesser number of electrons, so the size of the atom decreases. Okay, which make it hard to lose 4 electrons. Okay, you understood that greater number of protons are attracting the lesser number of electrons. So the size of the atom is continuously decreasing. And since the size of the atom is continuously decreasing, so as a result, large amount of force will be required to remove the electrons. Okay. So it is very tough, and that much energy is not available. Okay, practically available to remove all 4 electrons. So this is not practically possible that carbon can lose 4 electrons and form C4 positive ion. Okay. Okay. The question comes why carbon can't lose 4 electrons and form ionic bond. The reason is because it is start losing electrons, the size of the atom decreases, and since greater number of protons are attracting the lesser number of electrons, and it is very tough to remove electrons, large amount of energy is being required. Okay. Similarly, if a next, please take the screenshot of this one because we're going to have this question in your homework. Okay. Please note this question. Take this screenshot of this one. Done?
Done, sir.
Is there anyone? Should I move to the next slide?
Yes, sir.
Okay. Now moving to the next part is another question comes that why carbon cannot hold cannot gain 4 electrons and form C4 negative ion, because a powerful nucleus is being required to 4 electrons, which the carbon don't have. Okay. So what is the conclusion? That carbon make covalent bond. Okay. Covalent bond. So covalent bond is that bond that is formed by sharing of electrons. Here the two nucleus are there. Okay. For example, if I talk about this methane or CO2. So if I'm talking about CO2, in the structure of CO2, this is carbon 4 electrons. and this is the oxygen 6 electrons. Okay. So if 6 electrons are there in oxygen, then how many electrons it required to complete its octet? Tell me. How many electrons are there? 2. Only 2 will required by oxygen to complete its octet. So oxygen out of 6, okay, that way oxygen is going to have 2,6 electronic configuration, and it required only 2 electrons to complete its octet. So when 2 electrons are added, then it will start sharing electrons. Okay, means it required only 2 electrons to share to complete its octet. So what it will do? It will start sharing its 2 electrons. So here is the 2 electrons. Okay, similarly, this is the 2. The maximum one oxygen can share is 2 because it requires only 2 electrons to complete its octet. So it will share only 2. So here this is carbon. So carbon is going to have, I'm just making it with cross carbon electron. So here it is carbon. Now this oxygen is going to complete its octet. This oxygen is going to complete its octet by sharing of its 2 electron. And now this carbon is going to have it to complete its octet. Okay. So for some time, when this 2 electron and these 2 electrons revolve in the orbit of carbon, the carbon is going to have 8 electrons. And for some time, when this 2 electron and this 2 electron revolve in the orbit of oxygen, then oxygen is going to have 8 electrons. So both oxygen and carbon are going to be stable. So this is a structure that how covalent bond is formed. Similarly, if I'm going to have nitrogen in nitrogen N2 molecule, so in N2 molecule, nitrogen is going to have 2,5 electronic configuration. Tell me that how many electrons are being needed to complete its octet? How many electrons are being needed here? Tell me fast. There are 3 electrons. So there are 3 electrons is being required. So they will share 3, 3. If 3 electrons being required, they will share 3, 3. If 2 electrons are being required, they will share 2, 2. If okay, so this is going to have 5, but only 3, 3 will share. So 3 here will share, 3 here will share. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, if I'm talking about the O2 molecule, you can make it at home. Okay, N2 molecule I have discussed. CO2 we have discussed here. Methane CH4. So this is H, and this is carbon 4 with 4. And this is hydrogen. This is going to complete its octet. This hydrogen is going to complete its duplet. Sorry. Okay, this is going to complete its duplet, and this is going to complete its duplet. And similarly, this carbon is going to complete its octet like this way. Okay, so this is called covalent or sharing bond. Okay, you understood? So please take the screenshot of this one. Please take the screenshot of this one also. You have to make it at home. Done? Taken?
Done, sir.
And this one also. The last, take the screenshot of this one also. Done? So that's all for today, dear students. In the next class, we're going to discuss the graphite and diamond structures and the anomalous behavior of diamonds and graphite. Why diamond is very hard and graphite is good conductor of electricity, and if we can discuss the homologous series, functional group. So please do not miss the class, any class of this chapter, because this is organic chemistry, and organic chemistry is tough means students generally feel that organic chemistry is tough. So for them, I need to keep in mind, and if your basic is clear, because this is the first chapter that you're going to study as an organic chemistry. In up to 9th standard, you are not studying anything about the carbon or hydrocarbons, but in this chapter we're going to study. So this is the first and basic chapter. If you miss this one, then you